In this video, we're going to be running a correlation and a multiple regression. This data set is investigating a large state university in the Southeast where a new faculty rating system has been initiated. The Director of Institutional Research at the university is asked to investigate the faculty's reaction to this new rating system and determine the association between their reaction to the rating system, their age, and the perception of their work environment. The director randomly surveyed 13 faculty members. We're going to use SPSS, and we're going to now run a multiple regression and correlation and scatter plots. We can see that in our data set, we have 4 variables: faculty, which is a nominal measure of the participant's ID, reaction, which is a scale measure, age, which is a scale measure, and environment, which is a scale measure. So now in order to run the analysis, we'll go to Analyze, Regression, Linear. We're going to grab our reaction to rating, which is our dependent variable, and move it over into the dependent variable box. We're going to grab age and perception of environment, and we're going to put both of those in the independent variable box. Now we're going to select statistics. We're going to ask for model fit, which is already checked, R-squared change, descriptives, part and partial correlations, and collinearity diagnostics, and then click continue, and then click OK. And we're going to get a number of different boxes. So our first one is descriptive statistics of all of our variables. These are our correlations in the next box. You're going to look at the Pearson's correlation of reaction to the rating and age, and the correlation between reaction to rating and perception of the environment. And then we are also going to look at the significance values for each of those to tell us if those correlations are statistically significant or not. Then we have our variables entered, removed. This is going to tell us what variables are in the model in order to predict the reaction to rating. Then we have our model summary table, and our model summary table is going to give us our multiple correlation coefficient, which is going to be our R. It's going to give us our coefficient of determination, which is going to be our R squared. Then we have our ANOVA table. This is going to tell us if there is a significant predictive relationship between our independent variables, age and perception of environment, and our dependent variable, reaction to rating. So we would report this just like we report any other ANOVA, but this is where we find out if our model overall is going to be significant. Our coefficients table down here is going to give us information about each of our independent variables independently. So we can see in the first column we have our unstandardized coefficient. So for age, that's going to be negative 0.049, and for perception of environment, it's 1.158. That is going to be in the original unit of measure. So for age, it's going to be in years, and perception of environment, it's on the rating scale that they rated their environment on. And then we have our standardized coefficients, which is categorized by beta. These are going to be standardized units of measure, so you can actually compare them based on this column. So we can see that age is negative 0.168 and perception of environment is 0.807. We also have our t-value and our significance value for both of them. Here at the end, you can see your collinearity statistics. Your VIF is what you're going to be looking for to see if it is under 10. And then you have your collinearity diagnostics at the bottom as well. Now we're going to run our graphs to confirm if they have a linear relationship and what type of relationship that is. So we'll go to Graphs, Legacy Dialogues, Scatter and Dot Plot. We'll select the simple scatter and click Define. We'll move our reaction time onto the y-axis and one of our 2 independent variables onto the x-axis and click OK. We'll go ahead and do this for the second one: Graphs, Legacy Dialogues, Scatter and Dot, Simple Scatter, Define. We're going to remove age and we'll put in perception of environment and click OK. Now we can see on our output we have 2 different graphs. The first one is age versus reaction. So we can see that as age increases, the react time is actually declining. And similar graph down below is react and perception of environment.